Hi everyone, in this demo I will explain about HTTP service engine. This is very important class in our project. First, let me show you that class. Today I am discussing about this HTTP service engine. First, let me explain about HTTP request. Why this class is used. HTTP request. This class acts as a custom model to represent an HTTP request inside our application. Instead of directly using Spring's REST template or web client everywhere, we wrap all HTTP details into the single reusable object. This package is responsible for HTTP level abstractions like request and response. Here we used @data annotation. @data annotation is from Lombok, and it automatically generates getters and setters, for all fields, and toString method, equals method, hashcode method. This saves us from writing a lot of boilerplate code manually. So it is used to generate getters and setters, and also equals method, toString method, and also hashcode method. Automatically it reduces boilerplate code. Let me explain line by line in this class. See, this is a Pojo plain old Java object used across our service classes to combine our wrap and HTTP request structure. Now let's go through each field. Private HTTP method and its reference. This defines what type of HTTP call we are making. For example, HTTP method dot get method get or HTTP method dot post. When we want to fetch data, then we go through HTTP method dot get. Let me write it. When we want to fetch the data, then we go through HTTP method dot get. When we want to submit data, then we go through HTTP method dot post. And there are many methods. Next is private string URL. This is the target URL of the API we are calling. Private HTTP headers. This stores all HTTP headers like authorization, content type, PayPal requested ID. It stores all of it. It helps ensure that our request is authorized and formatted correctly. Next one is private object request body. This holds the actual payload or body of the request. It holds the body of the request. For example, if we use post or put, it contains the request body. If we use get, it can be left as null or empty. Let me write it. It contains the request body. We use get. Since it typed as object, we can store any kind of body like a pojo or a map or even a plain string. You will see this class being used in create order helper, capture order helper, get order helper. This class is used in all these helper classes. In those classes, we build an HTTP request object to set all details like headers, methods, and body, and then pass it to a generic HTTP client in our system and execute the request. And overall, HTTP request is a reusable model for building outgoing HTTP request. It keeps our code clean and standardized. Using Logbok helps minimize boilerplate code. It promotes abstraction and decouples request creation from execution. Next, let me explain about HTTP Service Engine. Now we are going to explore the HTTP Service Engine class. This class is responsible for executing outbound HTTP calls to PayPal. It takes in a custom request object, performs the actual HTTP call using REST client, and returns the responsible back to the helper or service layer. It also has strong error handling to cover PayPal downtimes and bad requests. Here we used class level annotations are two, @component and @SLF4J. First, let me tell about those two annotations. @component and @SLF4J. First, let me explain about @component. This tells Spring to treat this class as a Spring Bean, so it can be auto-wired and managed by the Spring container. Tells the Spring to treat the class as a Spring Bean. Next one is SLF4J. It is from Lombok. It creates a log variable for us, so we can do log.info or log.error, etc. without manually creating a logger. That means it is used to print the data in console without using system.out.println. In real time, we don't use system.out.println, we use logger. For printing, we use log.info method. Here we created one constructor, HTTP service engine. It accepts REST client. This class depends on Spring's REST class, which is a modern, fluent style HTTP client introduced in Spring 6. We inject the REST client using constructor injection, which is recommended for immutability and testability. Here we used one method, that is make HTTP call. It accepts HTTP request. This is the main method. It takes a custom HTTP request object and executes it. In this, first we will do the logging the request. Here we print the HTTP request. It prints the incoming request, so we can debug the data being sent to PayPal. Next, we execute the HTTP request. Here we used method dot method dot method. It sets the HTTP method like get, post, etc. And here we used dot URI. Sets the target URL. And here we used dot headers method. It adds the headers like authorization or content type. And next we used @body method. It sets the request body. And again we used other dot retrieve method. It executes the request. Next we used dot to entity method. It converts the response into a response entity. Let me write it to explain clearly. First we used dot method. It sets the HTTP method like getter, post, so on. Next we used @URI method. So dot URI method. It sets the target URL. Next we used dot headers method. It adds headers like authorization, content type, so on. Next we used dot body method. It sets the request body. Next we used dot retrieve method. And finally we used dot to entity. It converts the into a response entity. And it returns the response entity. Next we will do log and return response. That means we are printing the response entity and returning it. Once PayPal responds successfully, we print and return the full response. Next, we will discuss about error handling. This block handles 400 and 500 errors like unauthorized, internal server error, bad request, service unavailable. Third errors are managed by it. Next, we extract the actual HTTP status from the exception. Here we handling unavailable, that means 503 error, and or gateway timeout like 504. If PayPal is down or not reachable, we throw a custom exception with this code. This custom exception bubbles up to the controller where we handle and return a friendly error to the front end. For other known errors like 400, 404, 500, we simply return the PayPal error as to the caller so they can inspect the issue. Next, we have to handle unknown errors or timeouts. This handle cases like timeouts, DNS failures, or unexpected exceptions. Even here, we use our custom exception to gracefully handle system level failures. Here we handle errors like unavailable and timeout. Some custom exceptions like timeout cases when no response from PayPal. So today we discussed about HTTP. Here we discussed about HTTP request and HTTP service engine. Finally, the HTTP service engine is used to centralized component for a HTTP calls. HTTP service engine is the centralized component for all HTTP calls. It receives requests in our custom formats and uses Spring's Fluent REST client to execute them. We handle different error categories like 503, 504 network failures and combine them using our custom exceptions strategy. This helps keep our service robust, testable, and resilient even when PayPal goes down or returns unpredictable responses. This package contains all HTTP related things. This pack this package is responsible for the HTTP level abstractions like request and responses. So overall, today we discussed about HTTP service engine and HTTP request, and we discussed about some annotations that are used in these classes. We discussed about some methods and its uses. These are very important. It's very simple, but it's very important in your project. These are responsible for executing outbound HTTP calls to PayPal. It takes custom request object HTTP request like HTTP request, performs the actual HTTP call using REST client and returns the response back to the helper or service layer. It also has a strong error handling to cover PayPal downtimes and bad request. Thank you.